quiz. As you probably all of you know, it was a very easy quiz that I gave. I think that I just wanted to make at least one of the tests to be very easy. So I'm hoping most of you did very well. I think I'll post the grades by tomorrow. And today we are going to go through chapter 9, and we probably will go through chapter, I think it's 13, BI. I'm making a little bit of change to the syllabus as far as which chapter, the last chapter I covered. I would like to cover the business intelligence one because there are quite a few students in this class who are non-computer science major, and I think that's a pretty good topic to cover for folks who are non-computer systems or CIS or computer science major. So I'll make a small change to the syllabus, just the last chapter, so that this is also a good, unique opportunity for me to see whether teaching XML or BI is a better way to go. Every chapter, there's a question regarding which chapters will be in the quiz. So all the chapters we covered after the midterm, I think we, if I'm not wrong, we can go to the desire to learn and see all the chapters. But my guess is starting from chapter 5. So I will post exactly which. Okay, I think Daniel said it should be 5, 6, 7, 9, and 13. I think that's probably correct. So those are the 5 chapters. Then maybe the final will be exactly the same format as I had in the midterm, and the complexity of the problems will be exactly similar to what we had in the midterm. Some of you, very few of you, told me that there is not that you could have used a little bit more time. So in the final, I'll give 2 hours instead of 90 minutes that I gave last time. But the questions will be exactly similar to the type of questions, mostly short answer type questions, problems, and stuff like that. Okay, and again, so we'll do that in the next class, and then the last class, which is the 1st of August, next Thursday, we'll do the presentation, and I should have the grades for the presentation and all that by the end of next week, so that you guys can go to Desire to Learn and figure out what your grades are. We'll be presenting through this Collaborate. I have been told that there is a way to give you guys control. So I think I'm going to call them tomorrow and make sure how to do it. And I think I probably will post it on the Desire to Learn how to. I have been told that I can give control back to any of the students that I want to, and I don't know exactly how, but I think I can do that. So I'll just do that. And I have given you guidelines on what the presentation should look like. It's on Desire to Learn. So I think we're in good shape. Okay, so again, let me kind of summarize everything that we talked so far in this class. So that's because that's important before going into the last 2 chapters, which are kind of little bit beyond the core of what we were trying to teach in the class, but important, but not the core of what we. So if you look at the overall what we learned, what was the objective of learning in this class? The objective was to basically, if you have a business problem like you are doing in the project, you can take a business problem, convert it to a conceptual design, use the ER diagram tools, videos and ER diagram tools to produce a conceptual design, a ER model. From that, convert the ER model to a physical model, implement the physical model into a SQL Server database, and then be able to store and retrieve data from that database using SQL. So that is the core of what I have been trying to teach for last 12 or 13 classes. So the idea is that if you are in a business and you have been asked to solve a business problem, you know the steps, and the book kind of goes through in a not in a very straightforward way how to get there, but at the end it kind of ties everything together. So in this whole process, you can be the roles that you can play. You can be a business analyst, you can be a database developer, you can be a data architect. There are a group of people whose job is to primarily create data models. You can be a DBA whose job is to create those databases, and then you can be and manage the databases, or you can be a report writer or a knowledge worker who produces reports or stuff like that, or answers queries from senior management using the database. So that's what we try to get to. So I hope that you're understanding why we went through all these processes. So to do that, three things: you must have the analytical skills. Two, you should be knowing how to do Visio or any other ER diagramming tool to produce the ER diagram. Then from the ER diagram, you should know SQL to create those tables. Then after creating the table, you should be able to insert and retrieve data from the table. So that's the whole basic idea. Again, this is only one way to store. Obviously, if you knew programming language, and this class doesn't assume that any of the students who are taking the class know any programming language, so we didn't get into the details of the programming language itself. But there are other ways of doing the same thing, and in real life, probably you will not go through doing all the stuff that you do in this class into building a BI system. But if you are not a software engineer, you will be doing all the things that we taught in the class to do it. For a software engineer, there might be slightly different ways. But the basic skills, even the software engineer needs all these skills that we taught in the class, and they can supplement the skills with the programming language, which helps them to code systems which are more efficient or can be done quicker than what can be done with SQL. SQL is a pseudo language. It's not a full-fledged programming language. It doesn't have a lot of constructs of a traditional programming language, and it has its limitations. But on the other hand, it's relatively simple, and it empowers non-computer programmers to store and retrieve data from the databases. So one of the other roles, besides the role that I talked about, is that of a database administrator. And a database administrator is somebody who manages a multi-user database. When we talk about a multi-user database, that is primarily SQL Server, Oracle, DB2, all MySQL, all the kind of databases that we're talking about in this particular class are multi-user databases, and those are the databases that we will be in this chapter. We'll be talking about how to manage those databases. Database administration. All large and small data needs database administration. Data administration refers to the function concerning all of an organizational data assets. So the data administration basically means all the stuff that we have to do to keep the data safe and to make sure the database is reliable, safe, secure, and disaster proof. DBA refers to a person or a specific office specific to a single database and its application. A database administrator is I think there is a typo. It's not a database administration. This is database administrator. Is a person who is assigned to do the data administration. So what are the jobs that a database administrator does? They manage the database structure. Usually, like you said, when you created tables and you created a physical database schema. Those are usually done by the DBA. The DBAs are the primary keeper of the databases. The end user or a knowledge worker or a power user is the user of the databases. The job of the database administrator is to manage the database structure, control, so manage the database structure, making sure that the database is created properly, using, create and control concurrent processing, manage processing rights and responsibilities. I think this is control concurrent processing means that the database administrator makes sure that the database doesn't go to a unstable state. What do we mean by that? What we mean by that is that let's say you go to the ATM and you're withdrawing $100. So when you're withdrawing $100, the ATM has to, there are several steps, right? One of the steps might be that it debits your, when you go and punch in $100, that give me $100, it debits your account, and then there is another stuff happens. There is it sends some kind of system somehow sends let me kind of give a slightly different example. Suppose you are transferring money between your two accounts. You have your savings account and you have your checking account. Now you are transferring $100 from the savings to the checking account. So the checking account has to be debited. Savings account has to be debited by $100, and the checking account has to be credited by $100. So those are separate transactions in the database. So what happens that the power goes off in the middle, in the data center where the database is running, in the middle of the transaction. So it has debited your account, but it has not credited your other checking account. So there are techniques that we can use to make sure either both the transactions go through or none of the transactions go through. And that's some of the tasks that the database administrator helps in processing, because you don't want your savings account to be debited but not your checking account to be credited, to maintain data integrity. Manage processing rights and responsibility. That basically means who can do what. The database administrator is the gatekeeper. Database administrator makes sure that appropriate people have appropriate rights to do the stuff that they're doing, but don't have too much, that they should not see things they don't need to see. On the other hand, they should have access to everything that they need to see. So they manage the security. They develop database security. This is also to make sure that there is none. The first one is to making sure who can see what, when, and how. The second is to make sure prevent unauthorized access to, how to stop hackers from getting into the system. What kind of technology or processes you put in place so that people with only appropriate security level can see different things. Provide database recovery. So what happens if a hard drive fails? What happens if the building that the database is on goes to fire? What happens if there is a terrorist attack? What happens if there is an earthquake? So the job of the DBA is to think of providing techniques, redundancies, and strategies to make sure the database is on, is available all the time. Okay, can you guys hear me? I think I suddenly lost connection. Okay, for 20 seconds or so, collaborator came back and says lost connection. I have no clue why, but okay. So that's the job. Manage the DBMS, maintain the data repository. So that's what the DBA does. So participate in database application development, assist in requirements test and data model creation. That's what they do, the data model. Play active role in database design and creations. Facilitate changes to database structure. Seek community-wide solutions. Provide configuration control. Prepare for problems after changes are made. Maintain documentation. So basically, they help design the logical design. The conceptual model. They help design and make changes to the database structure. They prepare documentation. They do the disaster recovery. Lots of things that the DBA is responsible for. Concurrency control ensures that one user's work does not inappropriately influence another user's work. So, like, if two people, the concurrency control basically means, let's say there are two people working in HR, and one person's job is to keep track of where employees are located, which floor or which cube the employee is physically located. And then there is another person's job is to update where the employees typos. So if two people are accessing the database at the same time, it's possible that the second person overrides the changes that the first person makes. So the concurrency control makes sure that only one person is allowed to make changes or updates to a row at a given time. So that's what concurrency control basically means. Basically means that two people are not overwriting each other's update. It makes sure that at a given time, only one person can update a particular record. Okay. A transaction or a logical unit of work is a series of actions taken against the database that occurs as an atomic unit. Either all actions in the transactions occur or none of them do. So this is called a transaction. Like I said, when you are transferring money from your checking account to your savings account, it is done through something called a database transaction. That basically means either both the debit and the credit is done or none of them is done at all. So that there is no inconsistency in the database. Your account cannot be debited, your checking account can't be debited unless the savings account is credited. And that's an example of a transaction. And as I was giving an example, I'm not going to go through this. If you do not do a transaction, your savings account might be debited and your checking account may not be credited because something happened in the middle. There was a problem in the system, the power failure happened, the hard drive failed. Lots of things can go wrong in that unit amount of time. So it's important that, so similarly, concurrent transaction refers to two or more transactions that appear to users as they are being processed against a database at the same time. So again, I have given an example that if two people, which is called a concurrent transaction, if two people are updating one person's, two employees are updating one employee's or one person's record, it is possible that one person overrides the update that the other person is making through a concurrent transactions, and inconsistencies can be done. So through a transaction, we can. So here is an example. User A, read item A, change item number 100, write item number 100. User B does read item number 200, change item number 200, write item number 200. The order of processing might be read item number 100 for A, read item number 200 for B, change item number 100 for A, write 100 for A, change item 200 for B. And again, I think you guys got the idea. I don't think this example makes a lot of sense. Resource locking. Resource locking prevents multiple applications from obtaining copies of the same record when the record is about to be changed. So locking basically means in order two people, as I said, two employees, so that they do not update a record and overwrite each other, there is a concept for locking. So when let's say employee A comes in, locking prevents multiple applications from obtaining copies of the same record when the record is about to be changed. So employee A comes in, gets the record, and then wants to change the location where the employee office is. And before he saves it, he or she saves it, another employee comes in and updates, brings up the thing and updates their title. So what happens is the second employee's changes override the change of the first employee. So in this case, what can you hear me now? Okay, so everybody can hear me. Okay, I don't know. This is the first time I see it dropped connection again, but I have no clue why. So this resource locking happens. Basically, that's what it is. So when the employee number, first employee comes in and they want to bring in a record, they lock it. When the second one comes in, they are unable to get that resource. The system says this thing is currently locked. You cannot update it. So that's basically what resource locking is. Okay, so there are two kinds of locks, and I think exclusive lock and the shared lock. The exclusive lock prohibits other users from reading the locked resource. The shared lock allows other users to read the locked resource but can't update it. So you can do exclusive. When you do the exclusive, it will not even bring up the record. If you do a shared lock, then you can bring up the record, you can read it, but you cannot update it. Okay. Okay, I don't think I'm going to. All right. Okay, let's talk about this deadlock, and I think that's as much as you usually want to know about locks. I don't think you need to know a whole lot, but you need to know that locking is very important because you don't want two people to override each other's update. So we lock it, and we can lock it in two different ways. One is a exclusive lock where you can prohibits other users from reading the log resource. A shared log, you can read it, but you can't update it. So those are the key differentiators. I mean, locking is a very important concept, but I don't want to get into a lot of details into that, because primarily you want to know how you lock it and whether you want a shared lock or exclusive lock. A deadlock occurs when two transactions are each waiting on resources that the other transaction holds. Allow users to issue all requests at one time, require all applications to lock. I think this is the same deadlock that you probably have heard in computer science classes again and again and again. Basically, if two transactions are waiting on a resource that the other transaction holds, they will never they will kind of get into a deadlock and will never come back. So not really. Again, I'm not interested in getting a lot of details about locking. Okay. So as far as locking goes, again, some of the things, as I said, the book goes into too much detail, and I think that's beyond the scope of this class. But as long as you understand what the locking means and what is exclusive versus shared lock, I think that's good enough. Okay. ACID transaction is one that is consistent. So we'll talk about why a transaction has to be ACID. ACID stands for atomic, consistent, isolated, and durable. So I think this is kind of a important. Atomic means either all or none of the databases actions occur. We already talked about why that is important with your checking and settings account example. Durable means database committed changes are permanent. That means there is no way to undo it. Consistency means let's see. Durable, okay. Then it says consistency. Means either statement level or transaction level consistency. Statement level consistency means each statement independently processes row consistently. Transaction level consistency means all rows impacted by either the SQL statement are protected from the changes during the entire transaction. Okay, something is going on today. This is the third time I lost connection. That's pretty annoying. Okay. So for a transaction, it should be atomic, durable, and consistent. The consistency can be at two levels, at the statement level or the transaction level. Each statement independently processes rows consistently. So each statement that we are doing in the SQL statement can process independently rows. All rows impacted by either the SQL statements are protected from the changes during the entire transaction. So no other kind of transaction should be changing any of the rows during a transaction. So there is no other transaction should be impacting the transaction, that no other statement should be impacting the statement that is being executed. No other transaction should use the should impact the transaction that is being executed. That's what basically consistency means. Isolation means application programs are able to declare the type of and to have the DBMS manage logs to achieve the level of isolation. So that basically means, so let's go back and kind of rephrase everything that we learned here. For a transaction to be, we want all transactions to be atomic, consistent, isolated, and durable. Atomic means we said it is either it does one or nothing, like the primary and saving factoring example we gave. Durable means once the changes have been made, the changes cannot be easily, they cannot be changed back. Means that is, there is something called a commit. A commit means that the data has been written to the database and cannot be undone, so that's durable. Consistent means that there is two levels of consistency. There is statement level of consistency and there is transaction level of consistency. That means no other transaction should affect a transaction, no other SQL statement should affect the SQL statement that's being executed. So they should be consistent in the Isolated basically means that we are able to make sure that when different users are not really able, or sorry, different users are not able to introduce inconsistency in the database by what they are doing through different kind of isolation levels. Read uncommitted, read committed, repeatable read, and serializable read. And we'll talk about that a little bit more. So these are, and I think I'll come back to the isolation thing. I think it's a little complicated, but I'll come back to that in a little later on. The atomic, consistent, isolated, and durable introduces why databases are important. The transactions are so important for databases. Okay, let's kind of talk a little bit about. Okay, let me get the post. So I think if you have the book, look at page 352, and the 352 kind of talks about transaction level isolation, and it talks about the term isolated has different meanings. To understand those meanings, a dirty read occurs when a transaction reads a row that has been changed, but for which the change is yet to be committed to the database. The danger of the dirty read is that the uncommitted change can be rolled back. If so, the transaction that made the dirty read will be processing incorrect data.
So what we're trying to do by read committed is if you know in SQL Server and all that, once you have done
Okay, we are losing connection again and again and again. So, so if you look at page 332, it kind of gives you an idea of what is the isolation level means. That basically means that you should not be reading data which is not uncommitted. You can set up what kind of, if there is a data in the database that is uncommitted, because you know there is something, a concept of commit and rollback in SQL Server. Commit means anything that has happened before that statement is committed, is been written into the database. Rollback means you can roll back of all the things that we have done. So by the isolation level of read, uncommitted and committed, you can make sure that you don't do dirty reads. You do not read the data which is not been committed. So let's say somebody is writing the data into the database and they are about to commit, and before the commit, somebody else comes in and marks a SQL statement. So do they get the data or do they get the data prior to the update? So by read uncommitted and read committed, you basically application programmers tell the system where how to implement um, the isolation level. So read to read uncommitted, committed, repeatable read, and serializable are basically to say, so if your isolation level is read uncommitted, dirty reads are possible. That means if somebody is writing something and they have not committed to it, and you read it before they commit it, and they decide to roll back instead of reading it, you can have some. If you are read committed, that means you are only reading. You are reading data that is after it has been written, then dirty read is not possible. Similarly, so again, I'm not really hung up on this. You go ahead and read that. I think it will make a lot of sense. But basic thing that I am interested for you to learn from this is that to understand the concept of a dirty read, why it is important that we do dirty read, and why SC to make a transaction atomic, durable, consistent, and isolated is important. And I think we've gone through each of them with an example. Like the example in atomic, we said everything has to happen. Durable means everything has to be committed. Consistent means that they have to be, we should be able to execute all the SQL statements without interference from another SQL statement or a transaction. It has to be Okay, are you guys being dropped again and again? Can you hear me? Okay, I don't know. I have been dropped at least 5 times. I have to again sign back in. Okay. Oh, now this is frozen. Let's see. Oh boy. Okay, I don't know why I'm being kicked out, but it's kicking me out like 5 or 6 times already. Okay, can you guys hear me? Now it's not letting me even load the content I have. Let's try again. Okay, now we'll be talking about, hopefully for a while, on cursor. And again, all these things, I'm just going to give you the basic understanding of all these. Not going to get a lot of details of a cursor is a pointer into a set of records. It can be defined using select statement. So what exactly is a cursor? Let's kind of talk about it. Because obviously you can't use cursor in a SQL statement. Cursor is usually used within a programming language. And what we do exactly is, in a programming language, when you say you do a select within a programming language, whether it is C# or VB.NET or Java, whatever you do, a select statement usually brings in a set of records. So let's say you say select, and let's you say it brings in 100 records or 10 records or 20 records. Then all these records are stored within a cursor, and then you can go through the record set programmatically. You can get out one of the records that you got. Say you got 10, you get the first one, you do something to it, you change it, modify it, then you go to the next and you do something to it. So there are 4 types of cursors. Forward only, the application can only move forward through the record set. Scrollable cursor can be scrolled forward and backward through the record set. Static. So I think as long as you understand that there is a cursor and you go move through the cursor to get to different records, you are in good shape. I'm not going to get into details of the cursor because the cursor is only valid when you are talking about programming language. It's not really something that you can do with SQL on a GUI front end or through the SQL Server console. Database security ensures that only authorized users can perform authorized activities at authorized times. Who can see what? Like as I said, even let's say you have a human resources database and there are different people who can see different parts of the human resources database to do different things. Somebody might be interested in updating your address. Somebody might be interested in location usage. Somebody might be interested in which department you work on. Somebody might be interested in your pay scale. Somebody might be interested in your benefits. Somebody might be interested in your vacation. So all these people need to have only select number of tables that they have access to, or even select number of columns in a table that need to have access to. There might be different levels of people who have access to, you might have average user levels person, then you might have a DBA kind of person, you have a manager in the HR department who might have a role, you might have the chief human resources person who have a role. So there are different kinds of roles that the DBMS can. The DBMS products provide security facilities that limit certain action on certain objects to certain users and groups called roles. So that's basically it. Who can do what in the human resources database. And those are the type of things that we are going to talk about. That is called DBMS security. Okay, these are kind of security guidelines. Well, obviously we need to run it under behind a firewall, apply all the packs, security packs, protect the computer on the DBMS. Obviously, this is not a manage accounts and passwords and plumbing. That is use a low privilege user account for DBMS service. Protect database accounts with strong passwords. Like you have a password which has a capital, which is numeric, maybe 8-character long. Those kind of things. Monitor friend login attempts. Frequently check groups and roles, role membership, audit accounts with null passwords, assign accounts to the lowest privilege possible, limit DBA account privileges. Again, these are the things that a DBA does, and I'm not really going to ask you exactly. Again, in addition to the database security, you should have security built into the application. That's basically the programming language that you write in, so that people have at least 2 levels of security, one at the application level, one at the Okay, so this is a. I think you will probably, if you are in software, you will have heard of this SQL injection attack. a SQL injection attack occurs when the data from the user is used to modify a SQL statement. User input that can modify a SQL statement must be carefully edited to make sure only valid input has been received and no additional SQL syntax has been entered. For example, users are asked to enter their names into a web form text box. User input Benjamin Franklin or true. Select start from employee. So let's say you have an application where you are saying, okay, I want to get a record of a particular employee, and to enter that, you are asking for the employee's name. So a clever employee or a hacker can go in there and he says, instead of entering Benjamin Franklin, they enter Benjamin Franklin or true. So what they did was, they, instead of finding one record, they found all the records. And this is an example of a SQL injection attack. That basically the user was able to get something that the user was not authorized to have. The user was supposed to have only the record of Benjamin Franklin, but the user was able to get all employees' record by saying employee name equal to Benjamin Franklin or true. That basically gave you everything that you are looking for. And so how do we prevent SQL injection attack? So this is when you have code inside a C# program or a Java program. We have embedded code that is called a inline SQL. And one of the ways to get around it is to not have inline SQL, but pass a parameter to a stored procedure. One of the things we talked about was that stored procedures are a lot more safer or than inline in SQL, and this is the reason. If it was a stored procedure, the stored procedure will be only asking for one parameter, and that parameter will be this. It will not take anything other than that particular parameter. It will say, I don't know whatever you're talking about, or true is not something valid, and it will reject it. But when you have embedded SQL, there is no way inside a C program or C++ or C# program, the application is open for SQL injection attack. Database recovery, that's what the database does. Recovery via reprocessing, recovery via rollback and rollback. If there is a problem that there is some kind of a hardware failure, or there is some kind of a natural disaster, or there is a terrorist attack, there are many ways to recover the database. It might be through reprocessing, it might be through rollback, roll forward, it might be because it took from database recovery. So what exactly happens? And I think whatever the book says, if there is a hardware failure, most databases are backed up to another server. So you have a primary server and you have a backup server. So every night, depending upon the application, it might be every night, every hour, every 10 minutes, every 5 minutes, or it might be even real time that they are backed up. So if one of the servers go down or the hardware fails, we immediately switch to the other one and recover the content from the backup server, and we build a new server and recover the data. If there is a disaster, the building is on fire, a lot of companies have remote database centers and database locations. They call them disaster recovery locations. So if there is an earthquake, or if the building is on fire, or a terrorist attack happens, then for that purpose, they do probably every few hours replicate their data from their current production location to a off-site, geographically dispersed location where a backup of the database is stored, and the DBA can restore the database from the remote location to the primary data center, or a replacement for the primary. If the building is on fire or the building went down, or an earthquake, they should be able to recover it pretty quickly. So that's basically database recovery means. Let's see what happened. All right. Okay, I'm not going to go through that. Okay, so that's pretty much you understood what a DBA does, how data is recovered from is recovered, what ACID is, what is the function of a DBA, why DBA is important, why we need to manage security on the database, why it is important that we write code in stored procedures instead of writing embedded SQL and opening up the systems to SQL injection attack. So I think this gives you a very good flavor of what a DBA does, why the role of a DBA to make sure that the conceptual design is correct, work with the analyst, create the conceptual design, implement the database, create the database structure, make sure the data is recovered, is backed up, that there is a recovery strategy, make sure the appropriate users have appropriate authority, and all the appropriate users have access to the system, not users who should not have access to the system, and also make sure that the ACID, the all transactions must follow the ACID principle, and I think I've given enough example of that to make you understand why it has to be atomic, it has to be consistent, it has to be isolation, and it should be durable. And so if you understand those basic concepts, I think you know what is involved in managing a multi-user database, and if you understand why locking is important. I think if you don't get anything, if you just get why locking is important in designing a database. And the example, if you remember the example of I am transferring my money to a checking account, to a savings account, and how do I make sure that this is an example of making it atomic, that when my savings account is debited, my checking account must be credited. And they must either both of them happen or none happen. The second principle that is of unlocking is if there are two people going to the same system and pulling up the same record exactly at the same time, and they're trying to update it. One is trying to update the employee's location, and another person is trying to update their salary. It is highly likely that the second person will override the first person. That basically means the update to the location will be lost. The employee on the salary will be. So it is important that when we retrieve that record, it is logged. That means the second person, when they come to grab the record to update the salary, the system will say, I am not available. So there are two kinds of locking, as we say. One was in one type of locking, you can be able to read it. In the exclusive rating, you will not be able to read it. It will say it's logged. The other one, you should be able to read it, but you should not be able to change it. So, okay, any other question before we take a break and we come back and get into the last chapter, that is the BI, the business intelligence stuff. And I think that will be pretty light. Okay, let me see that we don't get. Okay, we'll take a 15 minutes and we'll be back at 9 and we'll try to finish this BI. And again, I'm not going to go through everything from BI.